This is the 747-400. It's been 19 years since the first 747-100 or jumbo jet took to the skies. And even though the outside appearance is basically similar, the 400 series is almost a different aircraft. This marvel of modern technology is so sophisticated, it requires one less crew and yet can fly faster and with more precision than its predecessors. Gone are the familiar altimeters, gyro compasses and speed indicators. The new jumbo hosts video monitor display units which gives the pilot multi-information on every aspect of the aircraft's operation. The computers which control the new automated flight system allows precision flight to the extent that these monsters can be flown only metres above the ground with pinpoint accuracy. When the command is given, the 747-400, with its landing weight of 220 tonnes, is gracefully returned to the Earth. During testing of the new aircraft, tolerances are pushed to the limit. 12,000 parameters are measured and recorded, including all forms of engine failures. 1,500 hours are spent in the air and another 1,800 hours on the ground, with engineers and technicians monitoring every detail. It was during these tests the 747-400 was loaded to the maximum takeoff weight allowable of 892,450 pounds, or 404,815 kilograms, just over 400 tonnes. After takeoff, the aircraft climbed to 6,500 feet or 2,000 metres, breaking the world record of the heaviest commercial aeroplane to ever fly. Beside me now is Greg Newman, Engineering Maintenance Supervisor for Qantas. Now Greg, I've just been told that these machines fully loaded have a maximum takeoff weight of 400 tonnes. I mean, that's pretty impressive.
Yes, it is, Paul, but nearly half of that is taken up with fuel. The aeroplane carries 170 tonne of fuel at takeoff, maximum takeoff weight. That approximates to 216,000 litres.
216,000 litres? I mean, where's it kept?
Well, come on, we'll go and have a look and show you. This is our centre section fuel tank, Paul. It holds approximately 65,000 litres of fuel. It goes from the rear spar here to the forward spar and right across the centre of the aeroplane. This is the rear bulkhead of the fuel tank in the wheel well. This is the bulkhead of the fuel tank there.
Okay, so we've got 65,000 litres of fuel right here.
That's right. When we get in that tank for maintenance, you can actually stand up in that tank. It's that big.
That big, wow. Okay, fuel in the wings.
We have approximately 69,000 litres of fuel in these wings, and they're divided into 3 tanks. This is our inboard main tank here. Outboard of this engine, we have our outboard main tank, and outboard of that we have a reserve tank which holds approximately 5,000 litres of fuel. And they just call it a reserve because it's not always full, depending on the sector the aircraft's operating and what the fuel load is.
Okay, and I believe finally we have 12,000 litres of fuel in the tail?
That's correct. We have a fuel tank in the tailplane which holds 12,000 litres of fuel.
The Boeing 747-400, to say the least, has an amazing fuel capacity. In fact, when it's fully fueled, it will hold 218,000 litres of fuel. Now, to give you some idea just how much that is, that's about enough fuel to fill 4 suburban swimming pools or to fuel about 3,630 cars. There would hardly be anyone that hasn't asked the question, how do they get off the ground? Well, before we look at the lift function of the wings and the mighty power plants that drive the 747-400, let's first look at the ground support system. That is, the undercarriage, the wheels, the tyres and the brakes. On takeoff, they support over 400 tonnes, and if a tyre is to blow, it's normally during takeoff. This is usually due to the weight, the length of the taxi, the runway surface condition and high temperatures. But with 18 wheels, if a tyre does blow, it is normally only a concern to a maintenance engineer. As far as the passenger is concerned, the flight will continue on in complete harmony. 747 tyres are worth $800 each and are retreaded after 100 to 150 landings. The tyres are filled to 202 psi of nitrogen instead of air. Nitrogen is used because of the less expansion and less corrosion within the tyre. During landing, the aircraft weight is less because of the fuel burn-off. However, the forces on touchdown produces great strain on the total undercarriage system, including the brakes. Engine reverse thrust is used to slow the aircraft down and assist the brakes in wear, but the aircraft is fully capable of stopping by its own brakes alone. Even in an emergency situation where the pilots have to abort a takeoff, the brakes meet remarkable standards. This test at Boeing's test strip in Washington State sees a 747-400 fully loaded and travelling at 160 miles per hour brought to a complete stop. The glowing wheels is the heat generated from the brake pads. Pilots and test engineers after this exercise noted these results as a textbook finish. Did you know one engine on a 747-400 produces more thrust than all four engines of a 707? Well, you don't often get to see a 747 from this sort of perspective. And I must say, it's quite awesome. To fall off this tailplane would be like falling off a two-storey building. An interesting point about the tailplane is from about the gold stripe back, I was once told represents about $33 million. So let's look at some of its features. Connected to the tailplane is the elevator. Now this provides a downwards and upwards force so the aircraft can climb and descend. Now I'm standing on the tailplane or the horizontal stabiliser. Now this whole area of wing actually rotates upwards and downwards, and you can see the amount of movement by the two black marks on the side of the fuselage. Finally, it's the vertical fin or rudder, and that's connected to two foot pedals inside the cockpit. It works in conjunction with the ailerons and actually helps balance the aircraft in a turn.